Now, because many of these problems are just going to involve numbers, it's not always going to be, hey, this is an angle, or this is an arc, what's the measurement of the angle? In this case, it says angle ABC is 50. It says, hey, what's arc AC? Arc AC is 0. So don't just say 50. Don't just say 50. All right, think about, again, what's the rule? Well, ABC is an inscribed angle, which means it's equal to 1/2 of the intercepted arc. Well, in this case, that's 50. It's supposed to be half of whatever the arc is. Well, if that's true, then I multiply that by 2, and it's going to give me 100 for the intercepted arc. So AC is 100, because 50 needs to be half of whatever it is. And however you get there, that's fine. All right. Then it says, hey, what's angle CDA? All right, let's see, CDA. All right, and this is a very, very common circle thing, where you get one answer and you have to do something else with it, but the something else is not that complicated, and you actually can answer it sometimes out the middle step. So that is an inscribed angle, because the vertex is on the circle, which means it's equal to half the intercepted arc. Well, we just figured out the intercepted arc, which is AC, is 100, so it's half of 100, which is 50. One of the things that we don't do a lot of anymore is proofs that involve circles, and it's because we just don't get time to do that. They've taken most of it out of the reading exam. Proofs that involve circles are actually easier to deal with because the circle rules all get twisted together, and usually you can work your way through if you're really good at the circle rules. The quadrilateral rules and the triangle rules are all kind of all over the place. So in this situation, if it didn't tell you anything, it just said, hey, how do you think the yellow angle compares to the blue angle? You would look at it, hopefully, if you really understand the circle rules, and say, well, they both have the same arc, they're both inscribed angles, that means they've got to be the same. And that's good enough, all right, to get you through that. Okay, that's kind of the logic behind what's going on here. Good news is you won't get asked that question possibly ever. So as long as you can take the rules and apply them to numbers, you should be okay with most of the circle problems.